Hi everyone, today we'll be talking about section 3.3, properties of logarithms. So there are three properties which I'm sure you remember from your Algebra 2 classes. The first is the product property, and it says if you have log base b of x times y, then that translates into log base b of x plus log base b of y. Similarly, for the quotient property, if you have log base b of x over y, then you have log of x minus log of y. Now the power property says if you have log base b of x to the power of p, then that comes down and you have p log base b of x. All right, so let's apply these properties. The first says to express log of 96 in terms of log 2 and log 3. So this is used when, for example, you know what log 2 is and you know what log 3 is. And you can evaluate log of 96 by writing it in terms of those two. All right, so what we're going to do is first we're going to figure out what is 96 made of, right? So when you take 96, okay, and you do the factor tree, right? Well, 96 is made of 2 and 48. This is made of 2 and 24. This is made of 2 and 12. 2 and 6. 2 and 3. Well, what do you notice? You have 1, 2, 3, 4, 5 2's. So 96 then is 2 to the 5 times 3. So why don't we first rewrite that? This is log of 2 to the 5 times 3. Okay? All right, well, now what? We're going to apply this first property, and we're going to say, okay, so this is just log of 2 to the 5 plus log of 3. The 5 will come down, and this is 5 log 2 plus log of 3, and that's equal to log 96. Okay? All right, well, here's some more. It says to evaluate each logarithm. So what you want to do here is you want to write each of these numbers as powers of that base 2. Okay? So I know, for example, here this is log base 2 of what? Well, it's the square root of 32. Well, what's 32? It's 2 to the 5, and the square root is just to the power of half, right? So that means this is log base 2 of 2 to the power of 5 over 2. Okay, so what happens now? The 5 over 2 comes down, and it's log base 2 of 2, and I already know that log base 2 of 2 is just 1, because 2 to the power of 1 is 2, so this entire thing then is just 5 over 2. All right, next one. Here I have 3 times, right? And I have log 7. Now what do I have in here? I have 7 squared to the power of 1/6. Okay, so this is 3 log base 7, 7 to the power of 1/3. Using the power property, this is 3 times. The 1 over 3 will come down. Log 7 of 7. We know that this is 1. We know that this is 1. So the entire thing here is 1. Who would have thought? All right, here's another one. The 4 here will come down. So it's 4 times 3 ln of e minus 2 times 2 ln of e. And we've already discussed the fact that ln of e is just 1. So here we have 4 times 3, 12 minus 4, that's just equal to 8. Okay, this shows up a lot in Precalc, in AP Calc. in your SATs and so on. All right, so let's do another one. I have here ln of x squared times root e. So let's expand, right, using that first property first, the product property. This is ln of x squared plus ln of root e. Okay, so what does that mean? Well, that means that this is 2 ln of x plus, what's ln of e? It's ln of root e, ln of e to the power of 1/2, which then comes down. So it's 2 ln of x plus half ln of e. This is 2 ln of x plus 1/2. All right, so now we're expanding this one. So remember, when you're told to expand, however many terms there are inside in the argument of your ln, that's how many ln's or logs you're going to end up with. So here I have 2 terms, and I ended with 2 separate logarithms. I then simplify, right? So here, let's count how many elements we have. Well, I have 1 here, 2, 3. So when I expand, this is going to expand to 3 different logarithms. So let's go ahead and do that. This is log base 6 cube root of x. Now, whatever is in the denominator will get a minus sign, right? So the way I see it is, if the 36 is in the denominator, it lives downstairs. It's like a second-class citizen, so it gets a minus, right? So minus log base 6 of 36. Well, what about that y to the 4? Where does that guy live? Well, he also lives downstairs. He's also a second-class citizen. He also gets his own minus sign. Log base 6 y to the 4. Okay. So now this is log base 6 x to the power of 1/3 minus log base 6 squared minus the 4 will come down, log base 6 of y, and here the 1/3 will come down, the 2 will come down, so I have 1/3 log base 6 of x. All right, now what is this going to turn into? Well, it's going to be 2 times 1 minus 2 minus 4 log base 6 of y. So let's write it in more conventional form. The variables will come first, and then the constant. Okay. Here, the reason why I have an asterisk in front of this one is that whenever you have something like this, remember that this numerator is an entity of its own, right? So we put parentheses around that one. So now this is going to turn into ln of 2x minus 3. Okay, now what do I have left? I have a denominator now. I've got this in the denominator. And look at all the different things I have here, right? So let's do that. Minus ln of 3 minus, right? That's a lower class citizen as well. So it gets a minus ln of 4th root of xyz. Okay, so let's simplify that a little bit. This is ln of 2x minus 3 minus ln of 3 minus ln of xyz to the power of 1/4. So the 1/4 will come down. Ln of x, y, z. Now this needs to be simplified even further, right? So this is going to be ln of 2x minus 3 minus ln of 3 minus 1/4 ln of x plus ln of y plus ln of z. Okay? All right. So next, we're asked to condense. When you condense, you have to end with one logarithm or an ln. All right, so we're going to condense into one logarithm. Okay, so we're going to do everything in reverse order now. Okay, it's just like you're rewinding. Everything that came down and became a coefficient will now become an exponent. So that becomes an exponent. That becomes an exponent. And I have log base 4 x to the half minus log base 4 x minus 2 cubed. Okay? All right. Well, what is that? This is log base 4. Now I'm going to condense. I have one major log, base 4. All right, x to the half, this is, it's got a plus sign in front of it. It's going to go in the numerator. So in the numerator, I have x to the half, which is really root x. Yes, we read it as root x. Now, the next term has a minus in front of it. Second class citizen, it's got to go downstairs. X minus 2 cubed. And there you have it. All right. Okay, so here, one more time, all coefficients will become exponents. So this will be ln of x plus 1 to the power of 5 plus ln of x to the 6. Now, ln of x plus 1 to the power of 5. I have a plus here. That means I'm going to multiply by x to the 6. And it'll look like this. Okay, so let's take a look at another one. Okay, well, what about the change of base formula? Like I mentioned, your calculators have a built-in base of 10. And in order to be able to utilize that, if I'm given something like this, then I need to change that base into a base of 10. Now, I know that the newer models have a different setup where you can actually enter in any base that you would like. However, the change of base formula still shows up every now and then, and it's worthwhile for us to take a look at it. Luckily, it's one of the easiest things you will ever do this semester, or this year rather. What we do is we construct a fraction. Now, I have here log of 4 over log of 6. When I do that, I've now changed the bases into 10. So what I can do then is I can go on my calculator and I can put in log of 4 divided by log of 6 and that'll give me 0.774. Again, we always go to 3 decimal places. Okay, well, let's do another one. Here I have log 4 of 4,212. So this is going to be log of 4,212 over log of 4. Well, let's see. Log of 4. That gives me 6.020. Okay, and there you have it. If you have any questions, you're more than welcome to ask during class. For now, I will leave you with optional problems. If you want to get a head start, you can do the ones that are highlighted here. If not, you can always continue during class. Thank you.